Okay, in today's lesson, we're going to be looking at recurring decimals. So before we get started, just have a think about this question here. Can you prove that 0.9999999 equals 1? Pause the video, have a think, and we're going to come back to this later. Okay, so here you have today's title is recurring decimals. You can pause the video here and obviously have a task the slides and have a go at the questions. It was a little bit hard to read. I've got them typed up here. Okay, so you've got your answers here. Self-mark, which is converting the fractions to decimals. I gave you a little bit of help as well. And to go from there, there shouldn't be any real issues just yet. Okay. So, in your book, just write down a recurring decimal is a decimal where the pattern goes on forever. So instead of writing 0.99999, we can write to that 0.9 recurring. Same thing here, we did 5, 5, 5, 5, it goes on forever. That just saves us a lot of time, a lot of effort. Okay, model. How can we write these as fractions? That's what we'll be looking at. So, write 0.7 recurring as a fraction. So we're actually going to use algebra here. Let me show you. Let it equal x. For this one here, we're going to times it by 10. 10x. Now we can say that 10x take away x equals 9x, because 10 take away 1, 9. What else can we spot? Well, we know that 10x is 7.7777. It goes on forever. We know that x is 0.7777. Goes on forever. Well, what happens when we take them away? Oops. Well, 7.777 forever and ever takes away, they cancel out, don't they? So 7 take away 7, 0, 0, 0, 0. Here we are. So now we can say that 9x equals 7. Therefore, x equals 7 over 9. Copy that down and then have a go at this question here. Write 0.5 recurring as a fraction. Okay, you should get an answer as 5 over 9. Here's a few more models. I'm just going to talk you through these now, nice and quick. Let that equal x. Now we've got 2 here, so I'm going to times it by 100. 37.37. Take them away, so 100x, take away x, 99x, and then 37.37, take away 0.37 equals 37. Therefore, 99x equals 37, x equals 37 over 99. Here, question 2 we're looking at. Okay, where's the recurring decimal? Well, we can see that the 3/7 repeat every time. So Okay, now we need to sort of multiply this in a way where the 3, 7 pattern cancels out. So first we're going to times this by 10. So let that equal x. So therefore 10x equals 4.3737 and so on. Now we want to times this. We want to get another 3, 7 pattern. Well, we can't. We need to times it. We need to move that over 1. Essentially, we need to move our numbers over 1, 2. So we're going to times this by 100. So that's going to give us 1000x equals 437.3737. And now when we take them away, 1000x take away 10x is 990x. And you've guessed it, 437.37, because that's what it equals. Take them away, they cancel out, and you're left with equals 433. Therefore, x equals 433 over 990. And that is, and you can check on a calculator, which always helps. 433 over 990, you've guessed it, equals 0.437 recurrent. Okay, copy those two models down and have a go at these questions here. You've got 0.525252 and 0.152 recurrent. When you've done that, your answers should be, you're going to get, I'm going to do this nice and quick, 100x equals 52.52, x is 0.52, 99x equals 52, x equals 52 over 99, and this one here, you've got 10x equals 1.5252, 1000x equals 152.52, sorry, typo. Take them away, 990x equals 151, and therefore x is 151 over 990. Always good to double check. Yeah, that's good to me. Okay. Practice questions here, about 15 minutes. Have a go at these. Again, if you're on the slide, it's a task in case my video's cutting off one. So pause it here. Here are the answers to self-mark. And if you finish this quickly, if you finish it in about 10 minutes, here's an extension to have a go at. Here are the extension answers. And sorry, these are the answers, yeah. So you've got questions, answers, and you've got an extension in case you were quick. Here are the answers. Okay, I'm going to do another model for you. What happens here? We have to sort of recognize where the recurring decimal is coming from. So therefore, this is going to be 0.53 recurring. Same thing, I'm going to let that equal x. Well, I'm going to times it by 10. 5.3 recurring equals 10x. Times it by 10 again. 53.3 recurring equals 100x. Take the 100x. Take away 10x. Give you 90x. 53.3. Take away 5.3 recurring, and that leaves us with 48. X equals 48 over 90. Can you I think we can simplify this one. We can. That's going to equal 24 over 45. This one here, what does it mean here when we've got these two dots? This is always quite interesting. What it means is everything in between the two dots is your pattern. Let me explain. So this will equal 0.1, 2, 3, 4, 2, 3, 4, 2, 3, 4. Let x equal that. And it goes on forever. Times this by 10. Now we have 1.2, 3, 4, 2, 3, 4, 2, 3, 4, and so on. We want to get another pattern like this. So we're going to times it all by 1, 2, 3. Times it by 10, times it by 10, times it by 10. We're going to get 10 times 10 times 10 times 10. So we're going to get 10,000x equals 1,234 point, which is a bit nicer so you can see what I'm doing. 0.234234234. They all cancel out when we subtract them from each other. So 10,000x take away 10x is 9,990x, and that's going to equal, well, 1,234.234.234. Take away 1.234, you're left with 1,233. Therefore, x equals 1,233 over 9,990. Check that in the calculator, and yeah, it works. And your scientific calculator should automatically simplify that down for you. Here's some practice questions. Have a go at them. Pause the video or use the slides. Answers are here. And when you're done, this is the application task. I want you to do question 1 to 9, and only if you were comfortable and you move on to the extension earlier, do you do question 10 to 17. And you still want a little bit more homework for those who are really comfortable with the topic. This is an optional extension and stretch, and I will be marking anyone who does the application task and this extension. I hope this helps. Any issues, just comment away and I'll happily answer them. See you next week.